Okay, here we go, the one that we're all excited for, paper 6 from the grade 10 mocks this year. Let's have a look at what was happening and see how we might have been able to approach this. So, starting off, the investigation. The robot starts and moves 1 unit, turns, moves 1 unit. Okay, so we're following this process. So what's happening here is moved 1, turned, moved 1, turned, moved 2, turned, moved another 2, turned, moved 3, turned, and it forms this special grid, and it continues to turn and move in the same way. So there we are, we've got a good understanding of what's happening. Let's just move across and read. By continuing the spiral, show that corner 10 is at 3, 3. Okay, so we've got to flip back the page and continue to corner 10. So another 3, turn, down 4, turn, cross 4, turn. Oh, I'm not keeping track of the numbers. Let's just write in our numbers. That was 5 here, so 6, 7, 8, 9, and 10. What does it say then on the next page? By continuing the spiral, show that corner 10 is at 3, 3. Oh, hopefully we've done that. Ah, yes, there we are. It is there. 10 is there. Oh, missed it, but it's there at 0.33. Okay, now let's move on. The length of the spiral from 0, 0 to corner 4 is 6 units. Okay, so let's just read what it said there. It said the length of the spiral from 0, 0 to corner 4, 1, 2, 3, 4, 5, 6. And it's asking us then to find the length of the spiral to corner 10. Gosh, right, let's count. Oh, didn't think there'd be so much counting, did you? Paper 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Whew. So we can say the length is actually 30. Use your spiral to complete the table. Oh, okay, so what's happening? We've moved 1 twice and then 2. We actually know what's happening here. This was 2 1s and then 2 2s. And if I check it, it does add up to 6 that we're expecting. So the next one, 1 plus 1 plus 2 plus 2, plus a single 3, should give me 9. Okay, let's look. Next one, 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus a 4. That equals 20. And 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4. Oh, 4 plus a 5. Well, that's an extra 5. Am I still going? Sorry, I pressed something. That's 25. And here we've got 2 5s on the end, so that's going to be 30, which is a nice answer that we're hoping to get. Oh, let me just put it in like this, because that's what we're expecting. That's what we wanted. Okay. What's next? Table shows the length of spiral from 0, 0 to corner k, where k is an even number. Okay, so k is always even. That's something that's going to come into play. Term n, find a formula for n in terms of k. Well, I don't really need to give this a great deal of context, because n and k, I can see the link here between these two numbers. So the formula is for n, so it's going to be n equals. How does n equal? Well, it's equals to k divided by 2. And we can see that just looking at our numbers. Now, next one, part B. Use part A to show that the formula is this thing. Don't start with this. A lot of people started with this, and you're not gonna pick up marks for that. You have to arrive at this as your answer. Well, what we're going to hopefully focus on, the formula is for L. We've been given this formula for L, been given this thing here, and we've just worked out n is equal to k over 2. And I'm noticing in this that there is no n's, but there is n's here. So I'm going to make a substitution for k over 2 in place of these n's. So let's see where that leads us. We've then got L is equal to k over 2 plus 1. Okay, it doesn't quite look like this yet, so we're just going to go through our algebra and expand our bracket, see where we end up. So L equals k squared over 4 plus k over 2. And shall we create a common denominator? I might just to be sneaky and do that as 2 and 4. So I've got my common denominator. I can look at what I'm aiming for and see that I need to take out a factor of k over 4, which leaves me then as k over 4. Oh, wrong colour. K over 4 brackets. Yes, it works for k, and yes plus 2. So that should be L equals this, and we've arrived at it. Next part, show that the formula gives the correct length of the spiral from 0, 0 to corner 14. Okay, so corner 14, we're going to plug in now k is equal to 14, and let's see what we end up with. So 14 over 4 times by 14 plus 2. I might just write here k equals 14. It's quite nice to add that communication. You never know where that communication mark might be on offer, and it might help me. You never know. So k equals 14. So 14 over 4, we get 7 times 7 over 2, if we simplify, times by 16, which is going to be 8 times 7 equals 56. Now, we've got an answer, but we haven't shown that it's correct. We don't know that that's correct. We've just got this formula, and we hope it's correct. What we need to do is we need to go through this process in order to show that it's correct for the 14th one. Now, what I noticed when doing this is question 10 had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers added together, and 9 had 9 if we add them all up. And so we're going to have 14 numbers added together, following the same pattern as before. So let's have a look at this here. We need to say, we need to do 1 plus 1 plus 2 plus 2 plus 3. Let's just check how many we've added together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Bang on. Hopefully it adds up to 56. Let's check. 1, 2, 4, 6, 9, 12, 16, 20, 30, 42, 56. Fantastic. And so we've shown that it is correct for our formula. What's quite interesting there, which is it's leading us into on purpose, is for 14th one we ended up adding 7 at the end. How curious. Right, when k is an even number, find an expression in terms of k for the length of the spiral from corner k minus 1 to corner k. Let's have a look at the original diagram, see what we're referring to. So k was an even number, that was the first thing. So for instance, it might be 10. And we want the distance from k minus 1 just to k, so just this length here. Well, that was the final thing we were adding on, wasn't it? 1, 2, 3, 4, 5. And let's look at another one. For 4, the previous one was 2. For 8, the previous one was 1, 2, 3, 4. Ah, there's a link, funnily enough. And it seems to be half of whatever the value of k is, which is going to be our answer. So that is simply k divided by 2. And we can see it here in this as well. The 14th one here, k divided by 2 is 7. 14 divided by 2 obviously is 7, and so that works nicely. Next one, from corner k to corner k plus 1. Well, best to go and see it again. To k plus 1 is the next one afterwards. Now this one's going to be slightly longer. It's going to be this distance plus 1. 1, 2, 3, 4, 5, 6 in order to continue the spiral, I should say. So that previous answer we need to add 1 to. Let's go and do that then. It's flicking back and forth, isn't it? But anyway, we're there. K over 2 plus 1 which if we want to put in a single fraction is going to be k over k plus 2 all over 2. Might help us at some point. Using question 2b next. Find a formula for, in terms of k, for the length L of the spiral from 0, 0 to corner k plus 1. Okay, what was 2b? 2b here was the length from 0, 0 to corner k. So this thing is from 0, 0 to corner k, and we need to go to k plus 1. Well, we've got an expression for k plus 1. So this thing here is what we need to add, one of these expressions. We need to add it on to our answer to 2b. So our answer for 2b was k over 4 k plus 2, and we need to add on k plus 2 over 2. Expand brackets, simplify where possible. We get k squared over 4 plus, well, it's going to be 2k over 4 or k over 2 plus, if I now split this fraction up, k over 2 plus 2 over 2, so it's plus another k over 2 plus 2 over 2, which I'm going to write as 1. Now, if I combine k over 2 and k over 2, which I can do, there's a half k plus another half k, which is just k. So we get k squared over 4 plus k plus 1, which is, if I factorise that, you might spot that it's a nice perfect square. It's going to be k over 2 plus 1 all squared. Use your formula to show that the length of the spiral from 0, 0 to corner 7 is 16. Now, corner 7, we need to give it this context, is k plus 1. So k plus 1 is 7, k is 6. And I'd write that down. Again, communication. K plus 1 is 7. Therefore, k is equal to 6. So I'm going to do 6 over 2 plus 1 all squared. 6 over 2 is 3 plus 1, 4 squared, which is 16. Marvellous. That's what I wanted. Fantastic. A little celebration for myself in my examination. Let's move on. Okay, question 4. Corner in the spiral has coordinates x, y. Horizontal lengths are added together. So now we're just adding our horizontal lengths. So for 1, it's just a single 1, 1, 2, 3. Okay, fantastic. Let's see what's happening here. Well, what I'm spotting is that we're adding on, first of all, we're adding on 2 more each time, yeah? Clearly the numbers go up by 1, and we add on 2 extra ones each time. So I can just, with that simple pattern spotting, 4 plus 5 plus 6 plus 7 plus the next 2 numbers, 8 and 9, add them up, and bit of mental maths, 45. The other way you may have done this is to spot that we're adding 5 here, we add 9 here, we add 13 here, and I'm not sure what we're adding here. Maybe you're spotting it already. This adds 4, this adds 4, which means we should add 4 on the next one, plus 17 to give us 45. Marvellous. Now we're after the formula for this. So the formula in terms of x for h. So h equals, which means we're looking for a formula for this thing, and we want it in terms of the x's here. Now, it goes up in x's in a nice 1, 2, 3, 4, 5, so there's nothing to kind of watch out for. We're now looking to describe this sequence. So this work that I've just done is going to help me with that. It's the second difference, and that second difference is 4. So if I halve that, that gives me the coefficient of what would usually be n squared, but we're now doing it for x. So for h, it equals half of 4x squared, which I'm going to write as 2x squared. It gets me started on my sequence. Okay, so I've got h is 2x squared, but there's something else that I need to add on to the end, or potentially subtract, who knows. but we need to make sure all the rest of it. The rest of it's going to be a linear sequence, so I need the difference between h, my sequence 165, 28 and 45, and the sequence that I've got, which is 2x squared. So let's just do a little subtraction. So 1, in fact I'm going to clear that circle because it's not very neat. 1, 6, 15, 28 and 45. If I compare that to 2x squared, 2x squared is going to be 2. Let's just label this really clearly. Actually, I'm going to add some bits. So x, h, and 2x squared. These are the three things I'm looking at. X is 1, 2, 3, 4, and 5. 2x squared is 2, 8, 18, 32, and 50. And so now I will subtract them, see what the difference is. So let's do a subtraction here. The difference is minus 1, minus 2, minus 3, minus 4, minus 5. Now that linear sequence we could just describe as minus n, or in this case, minus x. So h is equal now to 2x squared minus x. There are different ways of doing this. Oh, that's not quite what I wanted. 2x squared minus x. There are different ways of doing this. I know people use a n squared plus bn plus c and have a whole process of going through, which is absolutely fine. Hopefully you arrive at the same answer. Now, let's have a look at what's happening next. Write down a formula in terms of y for the total vertical length v of the spiral 0, 0 from corner with coordinates x, y. So we're now looking at the vertical length. What I'll probably do is just again refer back to our original diagram and see what it is. So what we've got, just change tool somehow. So we're looking at our y coordinate and then the vertical length. So a y coordinate first of all of 1 gives us an answer of 1. A y coordinate of 2 gives us a vertical length of 1 plus 2 plus 3, which is 6. A y coordinate of 3, which they've just given us, gives us 1 plus 2 plus 3 plus 4 plus 5. And hopefully what we're spotting is that's exactly the same as we had for x. And you can flick back and forth to do it a little bit easier than I can. You could start filling in those values and see it compares favourably to the table. So let's, well, compares favourably. It is the same as the table. So let's write something down in order to try and gain some communication marks. So in vertical, we get y is 1, vertical distance was equal to 1. When y was 2, our vertical distance that we travelled in total was 6. When y was 3, our vertical distance was 15. And as I say, that's exactly the same as this table that we were given, but that was horizontal. It kind of makes sense because there's a bit of symmetry about what's going on in order for the spiral to continue. So we can say, vertical length v, I've just spotted a mistake that I've made. Vertical length v is equal to 2y squared minus y. It's the same thing. The mistake I spotted was I forgot to write this h equals, and that does matter. So h equals 2x squared minus x, v equals 2y squared minus y. Feels like we're getting close to the end now. Marvellous, we are. A couple more questions. K is an even number. Use your answers in part B and part C to show that the formula for the length of the spiral from 0 to K with coordinates x, y is equal to this. So the length, L, is equal to the horizontal plus the vertical, which was 2x squared plus x plus 2y squared minus y, or minus x, minus x, minus x. Eraser, minus x. But here, in this situation, x is equal to y for an even number. What have we got? L therefore has to equal 2x squared minus x, you could use any letter really here, plus another 2x squared minus x, which is 4x squared minus 2x, which I can say is equal to 2x minus 1. Marvellous. So we're given this, and the length of the spiral is 1560 to the corner with coordinates x, y. Find the value of x. Okay, so 1560 is equal to 2x minus 1. And you could have got this even if you hadn't got the previous answer, because we're just using this formula here. And we get 1560 is equal to 4x squared minus 2x. 0 equals 4x squared minus 2x minus 1560. I get the sense that things will divide by 2, and so 0 equals 2x squared minus an x minus 780. Okay, so we'll factorise this. To be honest with you, looking at this, I'm not going to try and factorise it. To be honest with you, I'll put this into the quadratic formula now. If you want to fancy a challenge, you've got time at the end, then you can obviously try and factorise, and it should go. But we get, using our quadratic formula, the first x value as being 20, or the second one, which is minus 19.5. So this is one we're going to choose. So our answer here is 20. And there we are. That section is now done.